Welcome back. In this video I'd like to show you something that I made about a couple of years ago on the same theme as my 3D video at the drawing board. This is a fully manual manipulator and a 3D pantograph on a 5:1 ratio, as you can see here. I'll let you have a look over it so you can see the parts that it consists of. You've got the main two-way block here. You've got adjustment for horizontal and vertical. It's up to the top of the shaft here. It's got a nice heavy stainless steel painted base there, weighs about 4-5 kilos, something like that. Painted it with a nice Cerakote finish. It's quite durable stuff, is Cerakote. And moving on to the main pantograph itself, I can zoom back out. Are we in focus? Yeah. Like any normal pantograph would move from left to right, what this one can do, it gives you an extra two facilities, not just left and right, but it'll also move in twisting motions. And you can see down here, if I can move down slightly onto this black surface, you can see the manipulator is actually in there. This one is a glass tube, and you can really see that how fine you can actually work with these. Whereas motors and computers can give you high accuracy, so can a steady hand. Let's say, for instance, if I put a mark on this little black, I don't know whether you can see that there, a pencil lead mark. Let's say you're using this in the biotechnical world to manipulate plant cells and things, which is what these are used for sometimes. You can just see just how accurate they can be, and very, very steadily move from one to the other. High accuracy, actually. It's quite surprising what the human hand can do. And it has an extra facility, and this pencil grip, if you want to call it that, you can also turn that, and it can turn the actual magazine itself. See the magazine turn in there? So you could call it 4D if you wanted to. 1, 2, 3, 4, multiple D if you wanted to be adventurous. So I'll turn that towards us, lift it up slightly so we don't hit the needle, and you can see the top of the mechanism there, how this mechanism works, using this little ring connected to the main shaft of the cassette down here. It really is fine. So I'll move that back round again, and works really well actually. It's very, very stable. Even at full stretch like that, it will not creep. I measured it overnight, put a measurement from the bottom there to the top, and come the next one and it hasn't moved. So that means all the tension is set correctly, which is set by these little screws in between here. You can see there's little nut and bolts, and you nip them together, which nips against these stainless steel balls inside here, which allow for the movement. So once it's set set and forget, and it has some counterbalance weights, stainless steel weights on this end to correspond with the weight of the arm itself, which gives it its stability. So it's a very, very handy tool. I have had some success using it to doing the artificial insemination of queen bees, which I'll have to do some videos on next spring once the bees start working again. But it really is an invaluable tool for those that want to go analog, as they say. and it stows away nicely there at one side, and I can show you the close-up of the cassette at the bottom. Focus. You can change these 3 holders, basically slip in between that little groove there and a little rubber o-ring, holds it nice and firm. And you can see that turning there. You can manipulate that to just fractions of a millimetre at a time. That's another interesting project that I did a year or so ago. Excuse the amateur filming. I don't do any editing software. You see what you get, basically. So there it is, my homemade 3D pantograph. Really will manipulate it into any angle you like. Weird and wonderful. Thank you all again for watching.